Welcome to Chemistry World. Today we will see stereochemistry, stereochemist and classification. First one, conformational isomerism. Second one, geometrical isomerism. Geometrical means cis and trans. Third one, optical isomerism. First we will see conformational isomerism. If conformational isomerism arises due to flipping or rotation of cyclohexane bond. For example, cyclohexane. See the structure cyclohexane. This has 6 carbon at a ring. What is the cyclohexane? First we will see this ring structure alkanes and are not standard static. It is not static. It means this structure is not standard position. It is flipping many types like chair form, boat form, twist boat form, off chair form. Mostly chair form and boat form only more stable, others is not more stable. See, this is the cyclohexane of boat form. There is also 6 carbon atom, 1, 2, 3, 4, 5, 6 at a chair form, 1, 2, 3, 4, 5, 6. This is the chair form, this is the boat form. The ring bond not stable in static, so it is makes many types. Second one, geometrical isomerism. Geometrical isomerism arises due to restricted rotation about double bond. It is occurs in a double bond alkenes. Note here double bond is static, but a single bond is not static. Okay, so we can't rotate, but a single bond is not static, but we can rotate it, but a double bond is we can't rotate it because it is static. For example, cis 2 butane. See the structure cis 2 butane. Here 2 methyl group same side, it is called a cis. 2 methyl group same side. Trans 2 butane. Here 2 methyl group opposite side, it is called trans. This is cis isomerism, this is trans isomerism. These two types of isomerism is called geometrical isomerism. Next, third one, optical isomerism. What is optical isomerism? Optical isomerism due to the difference in the arrangement of atoms or groups about a chiral carbon. See, chiral carbon. Here chiral or chirality, it means hands in Greek word. Optical means light. At chirality, a compound does not overlap each other, it is called non-superimposable For example, our hand, our both hand, it is does not overlap to each other. So it is called non superimposable. For example, this is the carbon atom, this is the A group, this is the B group, this is the D group, this is the E group. Here 4 different types of substituent. It is called asymmetric carbon or chiral carbon. Asymmetric carbon or chiral carbon. So please note this word: asymmetric carbon, chiral carbon and non-superimposable. So both are denoted the same. Next, once if we get chirality, it will be produces non-superimposable image. It is called optical isomers. And it is optical activity. For example, see the mirror. This is the mirror. This is the object. Just we can imagine it. So this mirror is at the, it is called achiral, because this mirror image is going to other side. But see here below, this mirror image is going to does not overlap. This is called chiral, non superimposable. This image is going to overlap. This is called achiral or a chiral superimposable. This image is does not overlap. This is called chiral, non superimposable. Say a chiral or superimposable compounds does overlap each other. It is not optical activity. But optical activity means this compound does not give optical images. There is no images, different images. Achiral molecule have superimposable mirror images. They are identical molecule. So we can identical both molecule. If give both molecule, we can identify easily. So chiral. The chiral means asymmetric. Asymmetric means it does not overlap each other in such a way that the structure and it has mirror image and non superimposable. This is give mirror image. It is called non superimposable. Achiral. Achiral means symmetric in such way that it can be superimposable on its mirror image. Achiral molecule are always symmetric at every center, but asymmetric molecule not like this. Note, we know that light vibrating in all position direction. Light vibrating in all position direction For example, if take monochromatic light, it means same wavelength. Monochromatic means same wavelength light. See the below diagram. So this is the monochromatic light. It is going to nickel prism. It gives plane polarized light. When monochromatic light ray passes through nickel prism, it is form plane polarized light. Next, if we can polarized light passing through container have solution form of compound. Container is the solution form of compound. Okay. Next, if we plane polarized light passing through container, light is going to clockwise direction or anti-clockwise direction. It is called optical activity. This is the monochromatic light going to solution. It gives clockwise or anti-clockwise polarized light. Say next, optical activity means it is the ability of a compound through a rotate plane of polarized light in clockwise direction or anti-clockwise direction. It is called optical activity. Next, if the plane polarized light is rotated in clockwise direction, the compound is called dextrorotatory. See, if the plane of polarized light is rotated in clockwise direction, the compound is called dextrorotatory. Next, if the plane of polarized light is rotated in anti-clockwise direction, this compound is called leviorotatory. See the symbol. This is dextrorotatory. This is leviorotatory. Sorry. Laptop is going to hang. The optical activity, if the plane polarized light, it is anti-clockwise direction, its compound is called leviorotatory. Dextrorotatory denoted D or plus clockwise. Leviorotatory denoted L or anti-clockwise. Angle or observed rotation. See, observed rotation is affected by path of light length. L is the time of the light travels through a sample and concentration. C is the how much of the sample is present that will rotate the light. See the below the diagram. This is the path of light. This place is concentration solution C. Next, observed rotation alpha depending on the concentration C and the path length L. Here we can brings the standard sample. Here we can brings the standard sample. Its terms is called specific rotation alpha. Specific means standard. If take standard solution or sample, it is called a specific rotation alpha. Specific rotation alpha, if we should take length as a 1 centimeter and substance concentration gram by 100 ml, or length as a 2 centimeter and substance concentration gram by 200 ml, so on. This is called a specific standard solution or specific solution. This is called standard or specific rotation alpha. Enantiomers. What is the enantiomers? Enantiomers nothing but dextro and levio isomers. It is represented D and L. For example, first one, lactic acid. See the lactic acid. See the lactic acid mirror image. COH, OH, this side methyl group, this side hydrogen, but Levia rotatory methyl group is going to right side and the carboxylic acid going to C is the same position. Carboxylic acid, both carboxylic acid is same position, but methyl group is going to another position. This is the mirror image of the lactic acid. This is dextro compound, this is levio compound. These compound are not superimposable. It is called optical isomers. These types of compound are non-superimposable or chirality or asymmetric. Please note these three words: non-superimposable, chiral and asymmetric. See, we can write lactic acid in this manner. See, in this manner. CH3 COH, H is left side, OH is right side. But mirror image, OH is left side, H is right side. Dextro isomer is the levio isomer. The D plus lactic acid, L minus lactic acid. So minus means, here minus means this compound is mirror image, that is given minus. That's all. Don't want confusion. Example 2. Say tartaric acid. See the mirror images. Here OH is going to left side, this OH is going to here right side. This is called a tartaric, D-tartaric acid, dextro tartaric acid. This levio tartaric acid. So another possibility of this both image of the compound, both are same compound. Another possibility, see the another possibility of this compound. this OH, another OH going to right side. This is called mesotartaric acid. This mirror is this mirror is this. So these both are enantiomer. This mirror image is going to meso compound. This is called meso compound. See, if you don't understand, please pause the video and see. So these both are enantiomer. This is mesoform and it is optically inactive due to compensation internal. This image is optical inactive. Optical inactive means this is the symmetric. Optical active means asymmetric. Next, Razemic mixture. Suppose we take 1 gram of dextrotartaric acid and 1 gram of levotartaric acid at exactly equal amount at 1:1 ratio. Solution, it is called DL mixture. A Razemic mixture is a 1:1 mixture of enantiomers and optically inactive due to external compensation. It is called DL mixture. Next, Diastereomers. Optical isomers having no any mirror images relationship are known as diastereomers. See, example, see this compound exam A, this mirror image is this. This mirror image is this. Here 4 compound are same, but there is no any mirror image relationship. So both all compounds are same, but there is no any mirror images relationship. Pair of AC, AD, BC and BD. There is no any relationship between AC, AD, BC, BD, each them. Example 2, see, this is the textile and mirror images. This is mesoform, not levoform, because this compound has no plane of this compound has plane of symmetry. This is called a mesoform. So this compound is symmetric. It is not give optically activity. So these types of compound mesoform, dextroform, this is the mesoform. Mesoform has the same plane of symmetry. That is why it does not give any optical activity, and this is not chiral compound. Both are same compound, but there is no mirror image between the two molecules. It is called diastereomers. difference between the enantiomer and the diastereomers. See, first, enantiomers are diastereomers that are mirror image of each other. Diastereomers are stereoisomers that are not a mirror image of each other. Second, present in pairs, there can be several molecules. There is no any pair of molecule. They had similar molecular shapes, but here different molecular shapes. Here identical physical properties except for the ability to rotate plane polarized light. Here distinct physical properties. Thanking you all. Please subscribe to the channel. More videos on the way. Thanking you. All the best.